rational exponents, that positive and negative. Let's see here, exponents. Other than the laws of exponents, we have learned laws of exponents in previous class. Now, let's go to the fractional exponents. Fractional exponents after rational exponents. The rational exponents we have two types: positive rational exponents and negative rational exponents. Coming to the next one, integral exponent of rational numbers. The base can be raised as a power and to the power of there is something. So that is called as integral exponents of the rational number. That we have positive and negative also. So starting with fractional exponents. The fraction is nothing but like 1 by 2, 3 by 4 and so on. The exponent is a fraction and we call as fractional exponent. For example, we take 2 power 1 by 2 or 3 power 1 by 3 and this is called as fractional exponent. So 2 power 1 by 2, 3 power 1 by 3. So these are fractional exponents and this can be written as square root of 2, and we have learned in previous classes that is about the square roots, square and square roots. In that, power 1 by 2 can be written as square root 2, power 1 by 3 can be written as cube root 3. So these are the fractional exponents we call. These are the examples of fractional exponents. The exponent is a fraction, we call it fractional exponent. So rational exponent. Exponent is either any rational number which is in the form of a by b. We call it rational exponent. For example, we take here 2 power 1. 1 is a rational number. That's the reason we call it as a rational exponent. So 1 is a rational number. It's a rational exponent. We take 2 power 1 by 2. It is also a rational exponent because 1 by 2 is a rational number. A by b. So all fractional exponents will become the rational exponents. So 2 power 1 by 2, square root of 2. So each and every fractional exponent will become the rational exponent, but every rational exponent will not be a fractional exponent. The reason is 2 power 1, if we take one of the example 2 power 1 we have taken, it's a rational exponent, 1 is a rational exponent, but it's not a fraction, 1 is not a fraction. That's the reason a rational exponent will not become the fractional exponent. So every fractional exponent will become the rational exponent. Is found. So in that rational exponents we have positive rational exponent and negative rational exponents. Positive rational exponents are, for example, 2 power 2. 2 power 2 is equals to 2 into 2 is 4. Positive rational exponent we call. And 2 power 1 by 4, for example, it's a rational number. So we'll write it as 2 power 1 by 2 square. So 2 power 1 square by 2 square. So 2 power 1 by 2 whole square. This is so this is positive rational exponent. We call it, let's take some other example for this. 2 power 1 by 4 rational exponent. It is also rational exponent. We'll take, we have already simplified. It's this kind of examples that we call as a rational exponent, positive rational exponents. The negative rational exponents are, we take 2 power minus 2, that can be written as a power minus n is equals to 1 by a to the power of n, that is 1 by 2 power 2, that is 1 by 4. We call it as negative rational exponent because there is a negative number as an exponent, as a power. That's the reason we call it as negative rational exponent, a to the power of minus n. So we write positive rational exponent, we have written negative exponent, negative rational exponent we have written. Going to the integral exponent of rational numbers. If there is 27 by 125 to the power of 3, so we call it as integral exponent of rational number. So the reason is we can write 27 as 3 cube. So this is 27 as 3 cube, 125 as 5 cube, goes to the power of 3. That's the reason we call it as integral exponent of rational number. The reason is here we can write this base as sum of the power, like 3 cube. We raise this base as a power. It can be expressed as sum of the power. That's the reason we call this is integral exponent of the rational number. So this can be simplified. So 3 by 5 whole power 3. 3 by 5 whole power 3. Power to the power we write. So excuse me. 3 by 5 whole to the power of 9. We write. So 3 into 3. So it becomes 9. So 3 by 5 whole to the power of 9. This is an integral exponent of rational number we call, and it can be defined as positive and negative. So positive already we got it here. So 27 by, we take some other example. So 27 by 125 whole to the power of 4 by 3. So this can be written as, we know that 27 by 3 can be written as 3 by 5 whole cube. So divide whole to the power of 4 by 3. So this is the form of a power n whole power n. Then it can be expressed as 3 by 5 whole to the power of 3 into 4 by 3. It can be cancelled. So 3 by 5 whole to the power of 4. So 3 by 5 whole to the power of 4. So negative rational exponent, negative integral exponent of rational number. So when we take this, so it becomes 27 by 127 whole to the power of minus 4 by 3. So when we simplify this part, so we get the same thing like 3 by 5 whole to the power of minus 4 by 3. We'll take it and we'll simplify that part. So we get 3 by 5 whole to the power of minus 4, and then we take into the numerator, it becomes 5 by 3 whole to the power of 4. So in that manner we will simplify that 27 by 127, 27 by 125. So 27 by 125 whole to the power of minus 4 by 3. So here what we understood is exponents. Other than the loss of exponents, we have fractional exponents, and in fractional exponents, every fractional exponent is rational exponent, and rational exponent can be expressed as positive rational exponent and negative rational exponents. We have discussed here, and integral exponent of rational number, we have discussed about this. The base of a number can be raised with something, so positive and negative.